Hello everyone, my name is Dr. KCH Apparao, working as an Associate Professor in Mechanical Engineering Department, Institute of Aeronautical Engineering College. Okay, today I would like to explain about cutting tool materials. So this one is the course outcome which is related to this topic. So at the end of the course, the students should be able to recall the importance of geometry of cutting tools, coolants, and tool materials for the analysis of material behavior during manufacturing processes. Okay, so first of all, let's see cutting tool materials. We already discussed the importance of the cutting tools in the previous class, and we already discussed the types of the cutting tools also. Okay. So single point cutting tool, multi point cutting tools, we already discussed. Okay, in manufacturing, we use different types of the cutting tools based upon the manufacturing process. Okay, so in manufacturing, so we have to manufacture different types of the materials based upon the requirement for the design. You know that manufacturing of any mild steel objects, some very hard materials, we have to manufacture or we have to machining process. We have to perform the machining process on very hard materials. Okay, very sharp material also. So based upon the material which will be performed or machining, so we have to choose the cutting tool. Suppose we can't use the carbon steel for the machining of non-ferrous metals like aluminum, copper, because those metals, non-ferrous metals, are very sharp materials, so you cannot perform the machining operation of those materials. Okay, so based upon the machining of the different materials, different work pieces. Okay, so you have to choose the right tooling, correct tooling. Okay, some for perform the machining operation on very hard materials, we can't choose the carbon steel tools or high speed steel tools also, because we can't perform the machining process on very hard materials. If you perform that, automatically we'll get some wearing of cutting tools. We'll get some wearing of the cutting tools. Okay. So based upon those problems, to rectify those problems, different types of cutting tools are available in the market. So based upon those, we have to choose the right cutting tool for the machining of the right material. Okay. So here we'll see different types of cutting tools. The first one is the carbon steel materials, low carbon steel, high carbon steel, like this one. Next to high speed steel also. So HSS, very common material for the manufacturing of machine tools, uh, tool materials, or cutting tools. So next one is the cemented carpets. Cemented carpets. Next one, ceramic material for the manufacturing of tool material. It means ceramic cutting tools. Next to CBN, cubic boron nitride. Okay. So we'll see what type of these cutting tools. What is the different compositions in those tool materials? We'll see. Next one is the diamond type. Okay, polycrystalline diamond type. So we'll see first of all we'll see the what are the different characteristics of a good tool material. Okay, so a good tool material should contain, or should have the good hardness. Very hard hardness is very important parameter. Okay. Otherwise it will get wearing problem. So we'll see what is hardness. It is the ability to withstand high temperatures without losing its cutting edges. Okay. So uh, if the cutting tool doesn't have hardness property, so in the machining process, automatically it gets the wearing problem. Automatically, the edge of the cutting is weird. Okay. So there is a chances to losing of cutting edges. Okay. So cutting tool should have the good hardness. Next one, it is very important in high speed cutting also, because in high speed cutting, due to the friction between the cutting tool and workpiece, so heat will be generated. Okay. To withstand those type of heat, that type of heat, the cutting tool should have good hardness. Next, we can increase the hardness of material by adding some alloying like chromium, molybdenum, uh, tungsten, okay, vanadium. So these are the very important alloying materials to improve the or enhance the properties of the materials of tools, cutting tool materials mainly. Okay, so these materials or these alloys gives the good wear resistance and also good toughness and mechanical shock resistance also. Okay. We'll see what percentage of chromium, what percentage of molybdenum, so what percentage of vanadium, so are adding to different materials of tool materials. We'll see those things also. So next one is the wear resistance. So this is the very important parameter. So the cutting tool should have good wear resistance. Otherwise, the life of the cutting tool will be reduced. So cost will be increased. You know this one. The ability to, what is wear resistance? Wear resistance is the ability to resist wear. Okay. So may cause poor surface finish in its absence. If there is a high wearing problem, so automatically uh, the cutting edge will be lost. We will get the rough surface finish. Okay. So these are the good characteristics of good, so required characteristics of good tool material. So next one, toughness is also very important. So it is the ability of material to absorb energy and plastically deform without any framing. Okay. So it puts the limitations to hardness of the tool. High hardness that gives the brittle and weak. Okay. So importance in the case of tools used for the interrupted cuts. Okay. Hence the tool must be utilized efficiently to the maximum possible extent before it can be ground or discarded. Okay. So because tool grinding or replacement costs are very high, automatically the life of the tool is affected by various parameters. We'll see those things also. So next to mechanical and thermal shock resistance also should be needed for the cutting tool materials. We'll see what is mechanical resistance, shock resistance, and what is thermal shock resistance. First of all, we'll see thermal shock resistance. Thermal shock resistance. Thermal, you know that thermal means heat. So it is the material's ability to withstand sudden and extreme temperature changes. Sudden changes in the atmosphere, sorry, in the temperature. Okay. So sudden and extreme temperature changes. So in those conditions also the material, the tool should uh, have the ability to withstand those variations in the temperatures. Okay. So the cutting tool should have the thermal shock resistance also. So similarly, mechanical shock resistance. The cutting tool material or cutting tool should have mechanical shock resistance. It is the ability of a material to withstand a shock that typically lasts less than 1 second. So due to the high loading and something, okay. So the tool should have the mechanical shock resistance. Next to uh, low friction is very important because uh, due to the low friction or less friction, tool life will be increased or improved. Okay, so better surface finish will get. Okay? So because friction leads to generation of the heat. Okay? So if the heat generated heat is more, automatically the hardness of the tool will be reduced. So automatically the tool wear will be increased and will automatically that leads to rough surface finishing also. So next, favorable cost. So this would be needed. Potential savings from its use, just to increased cutting speed and material removal rate also. Okay. So next to increase the life of the tool also. So based upon those things. Okay. So these are the just like required characteristics of good tool cutting tool materials. Now we'll see what are the different types of the cutting tools. The first one we'll see the plain carbon tool steel. So it is very common tool steel, tool cutting tool material, because so this type of cutting tools very cheap compared to others, because uh, you know that carbon steel is very cheapest material compared to others also. So we'll see the composition in the high carbon tool steels. The carbon percentage is it varies from 0.8 to 3 3 percentage. So high carbon. Okay. Next, silicon ratio is 0.1 to 0.4. Manganese is 0.1 to 0.4. Rest is ferrous. So this is the ferrous material. You know this one. Okay. So higher content of the carbon increases the wear resistance, but will make it brittle. You know that carbon content increases the hardness and wear resistance of the material, but it leads to brittle materials. You know that cast iron is very hard material, but it is a brittle material. You know this. So there are two categories to make this one, this high carbon tool steels. One is the water hardening. Next one is the oil hardening. You know this one. Next we will see what are the different characteristics of this high carbon tool steel. Uh, it is the low hardness. It has low hard hardness, but we require the high hard hardness. So automatically we lose the hardness above the 200, because if the temperature increases, the hardness of this material, this tool, will be reduced. So above 200 degrees, automatically the hardness will be reduced. So will not regain it on cooling also. So that is the main drawback of this cutting tool material. Okay. So poor hardenability. Okay. Next, easy to machine also. You can prepare this type of tool materials, cutting tools easily. Next, keen cutting edge can be provided easily. So we can provide the keen cutting edges also. Next, high surface hardness. So its surface hardness is very high. So these are the main characteristics of this material. Next, we'll see what are the different uses of this carbon tool steel carbon tool steel tools. Next, so it is used in tool of small section which operates at a relatively small speed. So for the this is preferable for the small sections, for the machining of the small sections at small speed. So it has many drawbacks. Okay, so limiting speed of And this cutting tool is 0.15 meter per second, very less. Okay, using large amount of the cooling here. Here also require the large amount of cooling because due to friction, heat uh, developed heat is very high because of the friction. Next, it is used to manufacturing of milling cutters, mainly twisted drills. Uh, Next to turning tools also, for mainly for the wood and magnesium and aluminum, etc. So these are the just like uses of high plain high carbon tool steels. Okay, so now we'll see next one is the low alloy carbon steels. Okay, so low alloy carbon steels for the manufacturing of the cutting tools. It means cutting tools of low alloy carbon steels. It is a very small amount of chromium, so molybdenum are used in this increasing for the increase of hardenability of these tools. So compared to low carbon steels, so here alloying some alloying we can see. So alloying of chromium, alloying of the molybdenum to increase the hardenability of the tools. So up to 4% of tungsten we will see. Okay. Okay. So this is the 4% of the tungsten. So the main purpose of the tungsten is it improves the wear resistance. So this alloying is very important. The main characteristics of this low carbon steels will see odd hardness same as that of the carbon steels here also, low hard hardness. Next to not suitable for high speed operation. Well, it is very similar to just like previous one, that is the plain carbon uh, tool steel. But here compared to that one, it has good wear resistance also. Next uses we will see what are the different uses of low carbon, low alloy carbon steel tools. Okay, so these tools that requires wear resistance. Okay, so these are main. It has good wear resistance. So these are used to make the drills and taps and rammers also. So reaming tools and tapping tools and drill tools. So for manufacturing of those tools, just this type of alloy carbon steels are used. Okay. So these are the next one is the medium alloy steels. Medium alloy steels. So it is very similar to carbon steel. Okay. So with the addition of other elements, so other elements like chromium, molybdenum, and tungsten. So the properties of the steel will be improved. Okay. So the properties are increased. So addition of chromium, molybdenum that leads to good hardness. Hardness of the material will be improved. Tungsten that leads to good wear resistance. Okay. So we'll see the percentage of different alloying, just like carbon percentage we can see up to 3%. So carbon percentage gives the good hardness. You know this one. Silicon, so that is the up to 0.4 percentage. Next to manganese also 0.25 to 0.75. So chromium, which is used to improve the hardness of the hardness of the material. So the value of chromium is equal to 0.4 to 0.8. So tungsten is the 1.5 percentage, very important tungsten. So that improves the wear resistance. Okay. So remaining ferrous, you know this one. So this is the chemical compositions of the medium alloy steels. Let's see. Next, high speed steels. So these are very important and common material for the making of tool bits in mainly industries. Okay, so mostly used in industries. You can see. So major difference is it permits the high cutting speed compared to carbon steels. Okay, so it also it has hard hardness, and good wear resistance also. Uh, Retention of the sharpness at the cutting edge. So it has good properties compared to uh, low carbon or carbon steels. Okay. So the chemical compositions are constituents of the high speed steels. You will see. So in which tungsten percentage is up to 13 percentage, okay. Chromium 4 percentage, vanadium 1 percentage, and cobalt is the 1 percentage. Okay. So we can call it like 1341 grading. So 1341 grading. Okay. So 13 tungsten, chromium is the 4, and 1 is the vanadium, cobalt. So this is the grading of high speed steel. So these are very common tools, uh, tool material for the manufacturing of the tools. Okay. So next one is the stellites. So these are very important materials. So it was discovered by Heinz Elwood Heinz in 19th century. It was in 1900. Okay, he got the two patents on this material. So based upon those patents, he started the uh, purchasing of these materials, newly invented materials also. We'll see what is the importance of stellites. Okay. So it is non-ferrous alloy. So high percentage is the cobalt here. So in the previous, we'll see we saw the all tool materials are belongs to ferrous, but this one is the uh, non-ferrous alloys. We'll see what are the compositions of this material. We'll see. So in which cobalt percentage is 40 to 50 percentage, very high. Chromium is very 27 to 32 compared to carbon and high speed steels. Okay. So tungsten percentage is also 13 to 29 percentage. Carbon is the 2 to 3. Okay. So because of this one, this is the just like cobalt and chromium, tungsten. These are the so non-ferrous materials. So finally, this one stellite is the non-ferrous alloy. High percentage is the cobalt. That is 50% of cobalt. You can see here also. Okay. We'll see the characteristics of stellite. The first one, it cannot be heat treated first. Okay. So that is very important property. Uh, so not as hard as the tool steels at room temperature. So at room temperature, it is very sharp compared to high speed steel and carbon steels, but it retains hardness at high temperature, very harder than HSS above 500 degrees Celsius. Okay. So when the material is heated, automatically it gets the good hardness. Okay, that is the main property of this stellite. Okay. So it is just like to compare it to other materials. If the temperature of the other materials increases, the hardness will be decreased. But it is just like opposite to other materials. If the here the temperature of this stellate materials increases, automatically hardness also increases simultaneously. You can see it is very harder than HSS also at above 500 degrees Celsius. Okay. So mainly uses of this one, you will see for rapid machining of hard materials, very hard materials. So we can use this type of tools. For making of the farm tools also, we can use this type of materials. Next, it is used in the tool and insert form. So we can see. So these are the very important tool material for the manufacturing of the tools. Next, next one is the fifth one is the cemented carbide. Cemented, it means ceramic materials. So fine crystal of tungsten carbide, we will see. Tungsten carbide is the very hard materials. Okay. So it is mixed with the cobalt powder. So tungsten carbide powder and cobalt powder. Okay. So these are binded with the sintering process. You know that powder metallurgy. So through the powder metallurgy process, we can manufacture this type of cemented carbide tools. Okay. So tools means we cannot prepare the complete tool. Just to we prepare the just to tips of the tools. We'll see what is the different tips. We'll see. Okay, it is manufactured by powder metallurgy process because so tungsten carbide powder and cobalt powder. So by the sintering process, we can prepare the new tool tip. Okay. So the uses of cemented carbide, see, the mainly machining of the cast irons. You know that cast iron hardness of the cast iron is very high. Okay. So next to certain abrasive non-ferrous LS also. Abrasive means very hard materials. You know this one, non-ferrous LS. For manufacturing or machining of those type of materials, very hard materials and brittle materials, we'll use this type of cemented carbide tools. Okay. Not good for cutting tools, cutting steels due to face wear. Okay. So can be reduced by addition of the titanium and uh, tungsten carbide. So by sintering process also. Okay. So next to grading, so we'll see. So there are two types of the grades here. Cemented carbide. One is the C grade cemented carbides. Next one S grade. Okay. So in which composition of tungsten carbide and cobalt, it varies. Okay. Here in the C grade, we'll see the tungsten carbide and cobalt powder composition is 3 to 16 percentage. 3 to 16 percentage. Uh, so because tungsten carbide with cobalt used as a uh, binder. Okay, the percentage of the cobalt is 3 to 16 percentage. You can see. Okay. Next to here, greater CO content we can see. Okay, so it gives the greater shock resistance also. Next to S grade, we'll see. S grade, instead of the cobalt, here titanium carbide powders will use. Titanium carbide powder is used. Okay, the ratio of the range of the titanium carbide is 0 to 10 percentage. 0 to 10. So next to tungsten carbide also will see WC. That is ratio is equal to 0 to 16 percentage. Cobalt binder. So cobalt is used as a binder for the sintering process. So these are the grade. Okay. Titanium carbide, it helps to reduce the tendency of chip welding and increases the hardness. That is the main advantage of the titanium carbide, very hard material, ceramic materials. Okay. Next, uh, tantalum carbide. So T. So tantalum carbide helps to improve the greater V resistance. So that is the main advantage of the this materials. So alloying gives the good properties, enhances the properties of the tool material. We'll see different characteristics of this cemented carbides. Next, so these are very high hardness. So these materials have high hardness over the wide range of the temperature also. Okay. Very stiff because high Young's modulus it has, and nearly 3 times of the steel compared to steel. It has good Young's modulus even. Okay. So very low thermal expansion also. Thermal expansion also very low. Relatively high thermal conductivity. So thermal conductivity very high. So through that property, the heat will be lost easily to the surroundings by conductivity. Okay. That can be used for the high cutting speeds, 3 to 4 meter per second. Okay. Very uh, high cutting speed. So for the performance of the mild steel workpieces. Okay. So these are the main characteristics of this material. Next one we'll see ceramics. Ceramics is also very important to tool materials. You know that ceramic materials mainly aluminum oxide, titanium carbide, so these things. So here mainly consist of aluminum oxide with other oxide like boron oxide or something. Okay. So main consistent is the aluminum oxide. Okay. So through here also through sintering process, the powder of aluminum oxide and the remaining oxides, so combining those with some binders, then just we can prepare the tool tips by sintering processes. Okay, sometimes aluminum oxide may be high has 97 percentage, you can say. So 97 percentage of aluminum oxide you can take. Sometimes 80% of the aluminum oxide with the titanium, magnesium, vanadium oxides also. Titanium oxide, magnesium oxide, vanadium oxides, or carbates also. Titanium carbide, magnesium carbide, vanadium carbates. Okay. These are the ceramic particles. Those have very high melting temperature. It means very hard materials. Okay. So these are prepared in the form of throwaway inserts or clamp tips. This is the process to manufacture these type of materials. We'll see different characteristics of this material. So it can be used at very high speed beyond the carbide tools also. So it resists the build up edges also. Okay. So it is very important to point, because we know that we already discussed the build up edges problem. Next, it produces the good surface finishing. So high speed gives the good surface finishing. It is very hard and good resistance to wearing. So wear rate is very less. So tool life also very good. Next, hot hardness also very high. It can maintain hot hardness up to 700 degrees. Okay. So for the carbon steels, you know that range is equal to 200 degrees. Above the 200 means the hardness will be lost. Okay. Low friction at rake surface compared to carbide tools. Extremely brittle and limited to continuous cuts. Okay. So this is the one of the just like just one of the drawback you can say. Next, to poor thermal conductors, high temperatures. Okay, because of the pure thermal conductivity, so temperatures lost, passing of temperature is very less. Okay. So these are the main characteristics of ceramics. Next, we'll see ceramic tools. You know that we already discussed this one. Aluminum oxide is known as ceramic tool. Aluminum oxide powder is prepared in the mold and pressed up to 300 kg per centimeter square, is applied and then sintered. You know that this powder metallurgy process, through powder metallurgy process, ceramic tools are prepared. Okay. The tool tip, so the mainly tool tips are prepared by this type of materials, because we can't prepare the complete tool bit, because the cost of this material is very high. Okay. So we'll prepare uh, the only tool tips will be prepared. Those tips are fixed on the uh, carbon stool, carbon steel tools, okay, either single point or multi point, whatever you can take. So this is the processing details about the ceramics tools. Next one is the cubic boron nitrate. So this is very important. We know this here. This consists of atoms of the nitrogen and boron, special structure. So this configuration is similar to diamond. We know the diamond structure. Do you know the hardness of the diamond also? So available as indexable inserts. The main characteristics of this one is very high hardness. It has good hardness. Next to, so very material next to diamond. Okay, you know the diamond strength and diamond hardness very high compared to other materials. Next, it also has good thermal conductivity, so good property. Next, it is chemically inert, so it doesn't mix with the other elements. You know this one. Uh, Next, uses of this material, we will see machining hardened tool steel and high strength alloys. So that is the main advantage of this one. By using this tips, we can machine the very high strength alloys, very hardened high strength alloys. Okay. So next, the grinding of HSS, high speed steel, so stellites. We already discussed these materials. Okay. So next one is the diamond tool. Diamond tools very high hardness. You know this one. So it consists of atoms of carbon arranged in the variation of abscissa structure. So this is called as the diamond lattice. You know this one. The characteristics of this material is high hardness, very hardest material. Okay. High thermal conductivity, good thermal conductivity. You can see it is two times than the steel. Next, lowest thermal expansion also up to just 12% of the steel. Very low coefficient of the friction. So because of this one, the heat generation is very less because coefficient of friction is very less. Very brittle. You know this very brittle because very hard material. Okay. Next one, uses. The main uses of this one is the producing high surface finish on soft materials. So that are very difficult to machine, like copper, very soft to non-ferrous material. Aluminum is very soft to non-ferrous material. We cannot perform machining on these materials by uh, high-speed steel, meaning low carbon steel tool bits. Okay, because we can't perform the machining operations, because by using these diamond tools we can perform machining operations on these very sharp materials. That is the main advantage of this one. High cutting speeds can be used nearly 150 meter per minute, very high. Okay. So these are the different materials. So uh, to manufacturing the cutting tools. So these are the just like cutting tips, because carbide, diamond, and ceramic, all these are very costed, high cost materials. We cannot prepare those prepare mm, prepare the cutting tool, complete cutting tool by those materials, because that takes very high cost. So then we have to prepare the some tips. So cutting tips. Okay. So main bit, cutting bits. Okay. So next we can insert these cutting tips on the cutting tool, low carbon cutting tool or high speed cutting tool. Okay, whatever it may be, you can see like this one. Okay, so this material we can in this place we can set the uh, like CBN materials or a diamond or next to uh, ceramic materials, whatever, just the based upon the workpiece material you can choose the tip of the materials. Okay. So these are the materials. Last one is the abrasives. You know that abrasive particles. Uh, these abrasive wheels, so mainly used for the grinding operation, not for the machining operation. You know this one. Abrasive grains such as mainly you can take aluminum oxide or silicon carbide. These ceramic particles have very high melting temperature. Hardness of this material is very high. Okay, so these are mainly used to prepare the grinding wheels for the surface finishing, not for the machining operation. So they are used to remove very small portion of the materials in the form of uh, fine particles. Fine particles. Okay, so it can operate at high speed, high cutting speed. You know that one. They have high compressive strength. They have brittle in nature. So hardest material means very hardest material, mm, that that is in brittle condition. You know this. So next to low bending strength also. These are the main properties or main advantages of the abrasive materials. Okay. So these are the different references books. You can refer these books to understand this topic very clearly. So thank you listening this class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.